All right, so let's up our game to talking about rational expressions. Okay, rational expressions are fractions that have variables in the denominator, sometimes in the numerator as well. If we're subtracting fractions that look like this, we need a common denominator. We just posted a video that talks about what that looks like when we're dealing with integers. Here's what it looks like when we're dealing with rational expressions or variables, right? We're still going to take our denominators and we're going to multiply them times each other. And whatever we do to the bottom, we have to do to the top, right? So what we end up with is 4x on the top. Now, one word of advice that I would say is when you're doing this combining of fractions with either rational expressions or what we're about to start doing with trigonometric expressions, don't, just as a general blanket policy, you don't actually want to distribute. In this case, we're just going to write the denominators as a product. Okay, we're not actually going to do that distribution. All right. And the reason that we don't do that relates to what we talked about at the end of this video. When we take this quote unquote shortcut by just multiplying denominators together, we don't get all of the time, we don't get the least common denominator. Sometimes we get a common denominator that needs to be simplified. Okay. At the very end. So it's gonna get pretty hairy pretty quick when we start looking at some of these trigonometric expressions. So we don't want to actually distribute this because we may actually have to end up factoring it back out and then canceling. And when that comes up, we'll talk about it. Okay, but just as a general policy right now, don't multiply these together and get that big product. Just write it as a multiplication expression like this. Okay, now the numerator, different story. In the numerator, we do want it to carry out those operations. So since I'm doing 6 times x minus 1, I am going to distribute this, okay, up top. Now, when I go to combine these, I chose this type of problem for a very specific reason. We're subtracting this numerator. So in the numerator, when we're subtracting multiple terms, we have to remember that we're subtracting all of the terms that show up here, okay? So what this ends up being, when I go to put this together as one fraction, I put my common denominator here on the bottom, and on the top, I end up with 4x minus 6x. Now, this is a plus 6, okay? So keep that in mind. All right, we're subtracting all of the terms when we're subtracting a fraction like this. So our numerator ends up being negative 2x plus 6 over x times x minus 1. And just to be sure at the end, right, to make sure we can simplify, we want to factor everything that we can. So if I take this negative 2 and factor it away from the numerator, okay, what I'm trying to do is I'm trying to just at least attempt to see if I can get x minus 1 out of this to be able to simplify. In order to get that x minus 1, I'd have to take the negative 2 out of the numerator, and then we end up with a negative 3, because when we take negative 2 away from positive 6, we end up with negative 3. So this isn't going to work out where it can be simplified, right? But in the end, we want to have that factored form of both the numerator and denominator if we can, okay? So are we working with rational expressions? No, but this is just an example of what we do when we're dealing with combining fractions. Get that common denominator fast, subtract all of the terms that show up. If it's addition, no big deal, but if it's subtraction, make sure we're subtracting all of the terms here. And then when we're done, let's look for the factored form of everything and see if there's any canceling that can happen.